So I will explain how can you create a virtual hardware. You don't have a real hardware, a real data acquisition hardware on your PC. That's why I will explain how can you create a virtual hardware. Using that virtual hardware, we will able to understand and we can learn a real-time data actions. The real-time data actions is not a very big issue. Okay, suppose you are a IoT engineers, you are embedded uh, embedded platform developer. You want to design automation platform, control system based platform, right? So each and everywhere you have to acquire some data from the sensors. Why? Because the sensor can interact with our physical environment. We have the large number of the different kind of sensors. Based on the sensors, based on the sensors, okay, we can acquire the data. What I want to say, if I will, okay, suppose you are working somewhere and you want to measure the temperature continuously. Suppose you are working somewhere and you want to measure temperature continuously. So for that you need to use temperature sensor. So we have 2 to 3 kind of a temperature sensor like thermocouple, RTD, and thermostat. So you can choose anyone as per your own requirement. Clear? Now the thing is that if you want to acquire any kind of data, so you need a sensor because sensor can interact with the physical environment. Okay, suppose you want to measure a pressure or load, okay, or you want to measure the distortion. So at that place you can use the bridge strain module, okay, Whetstone bridge mod based sensor, strain bridge based sensor to acquire the real-time data. Okay, and here the real-time data which we are acquiring, for that we are using the sensor, sorry, yes, sensor, load cell or pressure sensor. Why? Because we want to acquire the pressure data. Okay, if I am able to explain correctly, so please inform me, or if I am not able to explain correctly, then also inform me. Now, so what is our main target? Our main target is uh, just acquire data from the real time from our physical environment. Okay, if we are able to acquire the data from physical environment, that means we can easily we are able to interact. Okay, we are able to sense the physical environment, how the physical environment is behaving. We are able to sense, and by the generating data, by the controlling any hardware, by the generating data or by the controlling any hardware, we can completely interact with the physical environment through our embedded programming or through our automations programming or our computational programming. So in data acquisition there are two parts. There is a there is one sensor who will acquire that, who will sense the physical changes, and using the data acquisition module we can acquire the data, and after the acquisition we can analysis and we can take the output. Okay, we can take our desired output. After the desired output, we can generate some information to rotate any motors, to control any physical objects, and that is data generation. And all these things you can do using one DAQ. Okay, so now come here and search in your PC and open NIMAX. When you will click and open NIMAX, so it will take few seconds, then you will get NIMAX platform. You will get NIMAX window. Now here I am going to search NIDAQ. If I will search NIDAQ and open here, so you will get data acquisition system, drivers and softwares. Data acquisition system, okay, device and softwares. Now here I am coming into the image. Now you can see this one, this image. You can see it is a complete data acquisition system. Why? Because here in this computer we have one software, data acquisition software. In this computer, we have one data acquisition software, okay, and this is the data acquisition hardware. Using this hardware, this one is my data acquisition software, and this one is my data acquisition hardware. Using this software, we can read, analysis, store, and display the recorded data or real-time data. This is the data acquisition hardware. Using this data acquisition hardware, we can acquire the data. These are the data acquisition modules. Okay, signal conditioning modules. You can connect the sensor directly to this signal conditioning module, and you can start data acquisition. You can start the data acquisitions. You will get the variety of the data acquisition module in the market or on only national instruments. Okay, as per your own requirement, you can select. Suppose you want to measure the data in temperature data, pressure data, vibration vibration data. Suppose you are working in a company who makes a washing machine, and there you want to measure the vibration of the washing machine. So for that you need a vibration sensor, and if your vibration sensor is giving output in terms of voltage, so you need a voltage data acquisition module. Why? Because your sensor is giving output in terms of voltage. Suppose if your vibration sensor is giving output in terms of current, so you need a current input module based on the sensor input module. Whatever the sensor you will purchase, first, okay, go and check the output. First, know about your sensor, how sensor is behaving, what is the range, and how, okay, and what kind of behavior it will show during the measurement, and what kind of output it will give to us. Based on the sensor output, go to the market and purchase your data acquisition platform. Suppose you have 10 different kind of sensors. You have a one sensor who can measure the pH, okay, pH of water and blood and other. One is who can measure only the alcohol. One sensor who can only the vibration. One sensor who can only measure the temperatures. But each and every sensor generate the data in terms of voltage only. So you need a voltage input modules. So we have this kind of the multifunction voltage input modules. So you can utilize it. Okay. Now you can see a data acquisition system. Data acquisition is a process of measuring an electrical or physical phenomena such as voltage, current, temperature, pressure, or sound. Okay, our data acquisition consists sensor, DAQ measurement hardware, and computer with programmable software. Great. Now we have the variety you will get. I am not telling you come to the NI only and purchase. You can go with the Arduino. You can go with the any other platform, Keysight, Kikisu, anywhere. But the NI is leading right now in the world for the data acquisition platform. Why? Because you will get the variety of data acquisition platform. That is not our target now. Okay, so you will get the different kind of the data acquisition platform. Some data acquisition platform will work will you can connect directly with the USB. Some okay, you can connect with Ethernet, and some will you can install on the your computers. Okay, some data acquisition platform you will get with the programmable, okay, FPGA and extra programmable facilities. You will get the different kind of data acquisition platform. Whenever you require a data acquisition platform, come to me anytime and ask me. I can discuss with you individually related to data acquisition module. In generally, we have some voltage based data acquisition module, because no matter what sensor or you have and what kind of the measurement you want to perform, but your sensor output is voltage, so you need a voltage data acquisition module. That's it. Okay, बात खत्म है. Suppose you have some sensors who give the output in terms of voltage. So okay, take only voltage, they give the data in terms of current, then take a current based data acquisition platform, current based DAQ. Suppose you want to only measure the temperature of some furnace, temperature of the boiling waters, temperature of any engine, and you want to measure the n number of temperatures, means not only one temperatures. If you want to measure only one temperature, then you can carry the thermometer, right? You want to measure the n number of temperatures. N number of means, suppose you have a boiler, okay, and you want to measure the temperature each and every section of the boiler. So you can put temperature sensor each and every section, and you can acquire the temperatures. Okay, sound and vibration. Suppose, okay, sound and vibration and pressure force. These are the measurement types. These are the measurement types you can measure. So if you come into the voltage measurement concepts, so you can measure the voltage in terms of the voltage RMS and in the millivolt range, and so many things you will get. And these kind of different data acquisition, voltage based data acquisition platform you will get in the market. You will get this kind of the different voltage based data acquisition platform. Look at here in the below section. Okay, in the top one, where is that? Okay, it is an you will get some analog, you will get the high accurate data acquisition platform like this. Okay, you will get high accurate data acquisition platform like this. You will get some your customizable data acquisition you can create. You can go with the multi-functions data acquisition platform you can take. Okay, and you can take some PC based. So different kind of data acquisition platform you can take based on the voltage. Same you can select the data acquisition platform for the current. Same you can select the data acquisition platform for the voltage. Okay, if I'm able to explain. So now okay, Arduino, you can use Arduino also. You can use Arduino for the some sort of data acquisition system. But there is a very big disadvantage with the Arduino, because Arduino cannot measure the high frequency data first. Using the Arduino, you cannot measure the high frequency data. Using the Arduino, you cannot measure the okay. Negative means Arduino can work with in between 0 and 5 volt. So you cannot measure the -2, -3 uh, millivolt or volt data. And also you cannot measure the 10 millivolt, 10 volt, 20 volt, 30 volt data, 60 volt data. Okay, so that is the there is only some kind of data acquisition you can do using the Arduino. But if you are an engineer, you are a scientist, and you want to measure the data, you want to measure the high speed data, you want to work on the data streaming. So you want to work on the IoT and very fast data acquisition you want. So come here and pick your data acquisition platform as per your own requirement, and go and okay, as per your own requirement, and you can okay, okay, after that you can measure the data. Now, so what is data acquisitions? My question is, okay, give it to me one option. Okay, data acquisition system. I'm not taking any kind of the my previous written or NIS platform NIS videos. I'm taking general ideas. Suppose it is data acquisition concepts. So in physical world, we have some kind of analog data, some kind of digital data, and some kind of counters. We have some kind of the analog data. We can pick the analog data. We can take the digital data. We can take the timer counter kinds of data. So these are my physical system. Here means, suppose in okay, there is one platform, physical system. On this physical system, you can put your in sensors. Okay, you can put your sensors. When you will put your sensor, so your system will, you have one physical system where you can insert or you can put your sensors, and sensor will sense the physical changes, and after that they can easily generate the data in sorry, they can read the data in terms of analog or digital based on sensor capabilities. Okay, after that after that okay, after that sensing, sensor will generate some electrical signal. Using the signal conditioning module, you can read that electrical signal, and using this analog to digital converter, you can convert. Okay, you no need to convert. You have only connect your sensor with the data acquisition module. Data acquisition module will convert your sensor into, sorry, your sensor signal, electrical signal into the analog to digital. Okay, and in between whatever the pre-amplify filtration, okay, whatever the pre-amplify and filtration and signal conditioning is required, the system will do, and it will, okay, and the DAQ module will pass the data to your PC, and you can easily read, write, and analyze the signals. Okay, now rest of the thing we'll discuss on the tomorrow. Now here I'm going to show how can we create some virtual data acquisition platform. Okay, so now let's open NI. Okay, my open NI Max. NI Max is short form of National Instruments Measurement and Automation Explorer. You have to search here and you have to open the NI Max. Now you can see in this NI Max, you can see here it is my data neighborhood. Okay, the first one is file, edit, view, tools, and help. The first one is my system and remote system. So here I'm going to click the my system. In this my system, the first one is data neighborhood, then device interface, then historical data, scale, and software. So using the NIMAX, you can read using the NIMAX, you can configure your all National Instruments hardware and softwares. Okay. Now you can see here in this my device and interface. In this my device interface, now you can see this yellow color NICDQ 9174. NICDQ 9174 is available here. So what is NI 9174? NI 9174 is a one hardware. NI 9174 is a one data acquisition hardware. Function of data acquisition system is not only to convert analog to digital. Function of data acquisition system, using the data acquisition system, you can acquire the data precisely. And data acquisition, inside the data acquisition system, you will get the signal conditioning module. That signal conditioning module will pre-amplify, first filter, first that will filter, then pre-amplify, then it will convert analog to digital, and after that the system will transfer your signal, your record, that's converted signal from the acquisition system to your computer, and that okay, to the computer, and based on your programmable software you can read, okay, you can read that signal, you can store that signal, you can analysis, so the complete package. Okay, A ADC module. Okay, each and every signal conditioning module, suppose here if I will take, okay, I will explain. So suppose it is my NI9174. NI9174 is chassis. Okay, this chassis will connect with your PC. NI9174 is chassis. This chassis will connect with your PC through this, okay, USB wire. USB wire it will connect, and four data acquisition module you can place inside based on your sensors requirement. Suppose I want to measure the okay, NI 9205. Suppose I have this NI 9205. It is a voltage data acquisition module. It is voltage module. It is a voltage module. Okay, so this capability of this voltage module is 100 volt, okay, plus minus 10 volt, sorry, plus minus 10 volt, and it is 250 kilo sample. Okay, the sampling is 250 kilo sample, and okay, it will do ADC, analog to digital conversion, based on the 16 bit. Okay, it has the 16 bit capability to convert analog to digital. Okay, and in this module you are getting the 32 channel, means you can connect 32 sensors. You can connect 32 sensors. You can measure plus voltage, you can measure the voltage, you can measure the voltage plus in range plus minus 10 volt. Okay, and the sampling rate will be 250 kilo sample. Okay, and it will okay. And now you can see first you have to connect your sensor like this. Okay, now after that it will convert ADC. Now you can see you can see here it's converting ADC. And look at here, if I will able to, okay, ADC, and it is ADC 16-bit ADC. It is 16-bit ADC. Before the ADC, it will be filtered. Okay, it will filter and amplify whatever the filter and amplify will require. First, it will do that filtering and amplify process. After that, it will convert your signal from analog to digital, and then this system will transfer your data. This system will transfer. The system will give a data to this system. Okay, through this connection cable. Okay, connecting terminal, and after that, using the Ethernet, sorry, using the USB channel, you can connect your PC and your data acquisition system, and you can transfer. You can able to read, and you can able to read, display, and store the data. Okay, so this kind of data acquisition module, this kind of the uh, okay modules, data acquisition modules we need. Okay, for the data acquisitions. Now, when you see here, I have this NI 9174. I have this data acquisition hard chassis. Then I have this NI 9235. Okay, NI 9235 hardware and NI 9208. 9208 is a current input module. It is a current input module, and 92 okay 9235 is a pressure measurement module. Now you can see here one NI USB 6001 is present. If you will see NI DQ6 USB 6001, so it is my another hardware. It is my uh, NI 6001. It is my a USB DAQ kind of hardware. Look at here, USB DAQ kind of hardware. You okay? NI USB 6001 can measure only the voltage data, and it can only generate the voltage data. Okay, if you will click, so you will get you will okay you will get to know in NID 6001 you will get 8 channel. Let's see, come here. Okay, look at here. In USB 6001 you will get 8 channel analog input module. 8 channel means 8 channel analog input 8 channel 8 channel analog input module means you can connect 8 sensors. Okay, to acquire data, and it can measure only the voltage data. Okay, yes, it can measure the analog signal, it can measure digital signals. Why? Because 13 digital input output bidirectional channel are available, so it can perform the analog input. You can measure the analog data, you can measure digital data, either you can measure the counter based data, right? Suppose you want to measure the flow rate or frequency, so you can use the counter. Now, but there is one academic hardware is available which I want to explain. NI my DAQ. In this NI my DAQ, it is a student data acquisition hardware which you can purchase for your own okay teaching and learning platform. Now, in this NI DAQ hardware, you will get okay digital multimeter. You will get some data. Just a second. Just a second. Okay. In this NIDQ hardware, you will get digital multimeter. You will get here analog input and analog out. You will get some analog input and output. Okay. You will get digital input and output. You will get analog input output. You will get digital input output. Okay. I think you can see. Okay. Now it is my NI my DAQ. You will get digital multimeters. Okay. You will get function generator FGN. You will get oscilloscope. Okay, you will get a digital input output 8 channel 1 counter. You will get power supply. It will able to, it can generate 5-volt power supply. Also it can generate a 15 volt plus minus 15 volt power supply. Okay, It is a student data acquisition module. Now, I will explain how can you create this data acquisition hardware. We don't have the real hardware, so how can we create this data acquisition hardware on our PC? So now here I am going to delete the previous hardware, which, okay, look at here. Now, device and interface, right click, create a new. Come here, create a new. Now, simulated NIDAQ Max hardware. Double click. When you will double click, you will get, okay, it will take few seconds, then you will get a pop-up window to search NIDAQ hardware. Now, you can see here the search option is here. Search option. In the search option, either you can see educational hardware. You can click on this educational hardware. Okay. You can see here the educational hardware. Double click and I my deck. So now it's constructing a NIDAQ hardware. Let's check. Come here. Open your LabVIEW. Come into the block diagram. Come into the measurement IO. Yes. Take. Okay. Take channel constant. Take a channel constant and click here. Now, okay, able to browse. Let's browse. Okay, no channel information is not here. Okay, right click, come here, come to data acquisition module. Okay, data DAQ assistant. It's taking a few seconds. After that, after the initializations, it will open a task bar. भाई थोड़ा धीरे धीरे टुक टुक टाक टाक करना भाई, धीरे धीरे पीटना, थोड़ा सा आवाज जोर जोर से मत करना पड़ो. Okay, now acquire signal, analog input, voltage. Let's see. Okay, now you can see NI MyDAQ, NI91, sorry, NI MyDAQ, NI MyDAQ1, NI MyDAQ, analog input 0, analog input 1. As I explained, in NI MyDAQ you will get 2 channel analog input, so we are getting 2 channel analog input here in terms of voltage. Let's come here. Okay, suppose if I want to acquire the data in terms of digital line ports, also you can see we are getting the 8-bit 8 channel, okay, 8 channel digital 8 channel digital input module. Okay, now here I am going to create one more hardware. Right click, create a new, simulated DAQ Max, double click, open it. Now again it's taking a few seconds, let's wait for it. Now you can see, now I need USB 6001, so you can directly search USB 6001 and add it. Now another hardware has been, okay, listed here. Come into the LabVIEW, right click, come to the measurement IO, open NIDAQ Max, take here and place here. Okay, now come to the acquire analog input voltage. Now you can see here we are getting two hardware. USB 6001 device, it has 8 channel, and NI-MyDAQ device, it has two analog input channel. Clear? Now here I am going to create a customized data acquisition platform. Come here, create a new, double click, why we are doing what we are doing. We'll learn tomorrow. Just create a virtual hardware 919174. It is my CDAC customizable data acquisition platform I want to create here. Now I had created NICDAC. Now I am going to configure the NICDAC. I want to take a voltage measurement module. So let's see how can I see NI voltage NI voltage input module. NI voltage input module. I searched. Okay. NI NIC series voltage input module. Okay. Let's check. NI current NI temp input module, temperature module, NI temperature module. Okay. NI temperature module. NI uh, pressure pressure module. NI pressure module. Now NI 9234 is NI pressure module. Let's see. So when you will come into the NI voltage input module, so let's here NI voltage input module. Now you can see the range of NI voltage input modules, and I want to measure the high speed and high accuracy. So 1 mega sample per second per channel data I want to measure 1 mega sample. Okay, so I have one hardware name, and that is NI9223. NI9223. Come into the your max, search here NI9223. NI92, sorry, again 223. No, again let's search NI9223. Yes, 9223. NI9223. Now come here, search here current input module. I want to measure the temperature input module. It is temperature input module. I want to take the high accurate temperature data, so I will select 923. Okay, 9234, 9234, right? 9232. I can select 9232, 9234, 9232. Let's come here. 9213. 9213, 9213, 9213, 9213. Okay, come here and let's check again. Strain measurement module 9235. So now, okay, now you can see using this hardware I can measure the voltage, temperature and pressure. Let's come here and again check it's we are able to use our virtual hardware or not. Okay, and log input or temperature, thermocouple. Now you can see I can use okay NI9213 module I can use for voltage in for uh, temperature measurement. Okay, I can also use USB 6001 and MIDAC, but this hardware, only this hardware will give me the data in terms of degree centigrade. Other you can measure in terms of the voltage and others. Okay, let's come back. Let's try to measure the pressure bridge. We have NI9235. Clear? So now tomorrow I will explain how can we start the data equations as okay, and we'll start the programming. Today is your work to design this virtual hardware.